In this clip, we will see how a confirmatory test is performed on an unknown substance. For drug detection, the method of gas chromatography mass spectrometry, or GCMS spec, is used to detect and identify substances within a compound. As a sample travels the length of the column in the GCMS spec, the molecules separate and the unique chemical properties of each different molecule cause them to travel at different rates. This allows the GCMS spec to detect and analyze the characteristics of the different molecules, thus helping the drug technician to identify the unknown substance. Dr. Graham Rankin will show us how a GCMS spec functions and how to read the results.
This is a gas chromatograph mass spectrometer. We heat the sample up, is heated up to a high temperature so that it is volatile, it becomes a vapor. The vapors are then separated, pass through this long capillary tube, which the inside of that tube contains a very thin layer of a compound, which serves to separate the compounds from each other. The inside diameter of this tube is smaller than a human hair, and it is almost 100 feet long, 30 meters. It then passes into the mass spectrometer, which uses a stream of electrons to hit the molecules of the analyte as they come out of the capillary tube. This causes them to break into a number of different fragments depending on the chemical structure of the organic molecule. We can match the the fragmentation pattern of our unknown against that of a known sample of methamphetamine to prove that it is what we think what we suspect that it is. We can also use the time it takes for the compound to pass through the column as an additional test that it is same as methamphetamine. Amphetamine and methamphetamine, although very close in chemical structure, have slightly different elution times, the time it takes to get through the column. We can use that with the mass spectrum to confirm that it's methamphetamine and not amphetamine or any other compound. This is a chromatogram, the top, of a true sample of methamphetamine. It comes out about 8 minutes into the analysis. At the bottom, we have the mass spectrum of methamphetamine. It has a fragment at 150 atomic mass units. It also has another fragment at 58 mass units. Aside from very small peaks out here that are unrelated to our standard, this is a clean sample. Here is our unknown. We also have our band at our peak at fragment at 150 and at 58, although the ratio is a little bit different from what we saw with the pure sample. Some of this may be due to the amount of methamphetamine spectrometer. We have our main peak comes out at 8 minutes in the chromatogram, the same as methamphetamine. We also have another smaller peak here at 8.622 minutes, which may be related to some impurity or some adulterant that the person who made this sample added to the methamphetamine. We would have to do additional tests to determine what this second compound is. Based on the gas chromatograph mass spectrometer, we have confirmed that our compound, our unknown compound, contains methamphetamine.
Now that the structure has been identified, the chemical structure is important information.
This is the chemical structure for methamphetamine. Amphetamine is another group of the same class, which is very similar in structure, but does not have this final methyl group at its end. In place, it has a simple hydrogen atom. Methamphetamine is commonly made by an illicit or clandestine synthesis from a compound called ephedrine, or a very similar compound, pseudoephedrine. You may know pseudoephedrine was the active ingredient in the common cold medication Sudafed. Because of methamphetamine was being made starting out with Sudafed tablets, the drug company that makes them has changed its formula so that it no longer contains pseudoephedrine or ephedrine. The compound it does contain cannot be made into methamphetamine.
Thank you for joining us as we learned about presumptive and confirmatory tests which are used in drug testing and analysis. Due to the frequency of the drug cases which appear in courtrooms, drug analysts are frequently called on to testify in court about the results of the tests they ran in their labs. They are able to confirm the identity of a substance, which typically affects the results of the case. Thanks to GCMS spec technology, drug testing has become more accurate and efficient.